JT, do we have anything in the inbox today?
Sure, Kim, let me check. Oh, so we got one here that's right up your alley. It comes from a customer who wants to know a little bit more about phospholipid removal. They know it's important to remove these phospholipids to extend their column lifetime and to mitigate matrix interferences. But their question is, as long as they're doing SPE of some kind, that'll remove the phospholipids, and that's good enough.
Okay, so they recognize that solid phase extraction removes phospholipids,
Yep.
but they're wondering if there's a difference between what kind of solid phase extraction they use. Is that correct?
It sounds right. And, we know a lot about SPE products, and we know that there's all sorts of different things. There's polymeric, silica-based, normal phase, mixed mode. There's like so many.
There are.
So does it make a difference on which one you use?
Yep. So when you're designing a sample cleanup to remove things like phospholipids, it's almost as important to think about what you want to remove, like the phospholipids, as it is thinking about how you can retain the compounds that you want to maybe concentrate or clean up.
Yep.
So I think what we could do maybe is design an experiment. Let's pick something that's really, really dirty with phospholipids, like whole blood.
Oh, yeah.
And we can run an experiment measuring the remaining phospholipids in that final sample eluate after we go through the solid phase extraction protocol. And we can monitor that to see if it matters which SPE sorbent you use and which method you use to see what the impact is, to see if all SPE would really remove phospholipids.
I think that's a great idea. Right, we'll look at the sorbent itself and the protocol.
Absolutely.
All right, let me get some stuff and we'll set up the experiments and we'll let it rip.
All right, let's go. So the first sorbent we're going to look at is one that was designed specifically to remove matrix components like phospholipids from biological matrices. And that one's Oasis Prime HLB. And that one has a 3-step protocol that was designed to be pretty simple to use. You don't have to have a lot of SPE expertise to do this. And it's designed to remove 95% of things like phospholipids using this generic 3-step protocol. So we simply load the pre-treated sample, then we wash it with 5% methanol, then we elute it with a solution of 90% acetonitrile, 10% methanol. And that method was chosen specifically to remove the phospholipids. So let's take a look at what the data looks like when we do this.
So Kim, the data I'm showing here looks really compelling. If you look at the little bar graph on the left, where we use 90% acetonitrile, which is specified in the protocol you just talked to, we remove 90 to 95% of all the phospholipids, which is really good. What I'm showing to the right here, what we see from the right, is that if we deviate from that protocol just a little bit and increase the organic content now to 50% acetonitrile, you completely destroy that extraction, and now you're getting a 5-time increase in the phospholipids.
Yep, you're exactly right. I mean, in this example, we used phosphatidylcholine and lysophosphatidylcholine to measure the total phospholipids that are present in that sample eluate. And even when using the same sorbent, so in both cases we're using Oasis Prime HLB, but the elution solution makes a big difference here. If we increase the methanol in that elution solution, now we're increasing the phospholipids and we're not removing them. So Jonathan, you talked about the Oasis Prime HLB example, and we just looked at that data. But there are other modes of solid phase extraction that you can choose from too. For example, the mixed mode, ion exchange, like the Oasis ion exchangers, and those have both reverse phase functionality and ion exchange functionality.
Yep.
So let's hone in on the Oasis MCX, for example, which is a strong cation exchanger. You typically use this with basic compounds. And we'll look at that with Protocol 1, where we follow this standard protocol, and then we elute our bases. And theoretically, we are believing that these samples are going to be cleaned up from matrix interferences like phospholipids, right?
Right.
Let's see what the data looks like.
So Kim, on adding to the data that we looked at earlier with the Oasis MCX, or cation exchange sorbent using Protocol 1, you can see that, boy, we didn't clean up any of the phospholipids. We see about a 14 times increase in that concentration when compared to the Oasis Prime HLB.
Yeah, you're right. I mean, we chose the Oasis MCX, which is a mixed mode cation exchanger. So it has reverse phase functionality, it has strong cation exchange functionality. And you think that with an orthogonal cleanup like that, you're going to end up with a really clean sample. But it really does depend on what's happening at each step and what your sample matrix is. So you can see that even with that highly selective cleanup, we're not removing the phospholipids with the standard MCX protocol. So we saw that there were a lot of phospholipids remaining with that mixed mode Oasis MCX protocol. What we can do is actually then take Oasis Prime MCX. And again, the Prime were actually designed to remove matrix components like phospholipids, right? So if we take this protocol, again, where we load our sample, and in this case, it's our typical dilution with 1-to-1 plasma to sample with 4% phosphoric acid. Then we wash with 100 millimolar ammonium formate with 2% formic acid in it. We wash again with 100% methanol. And then we elute with 5% ammonium hydroxide and methanol. And what that does is it turns the ion exchange retention off and also overcomes the reverse phase retention with the methanol. And we can see when we use this kind of protocol, it's quite different than protocol 1 that we followed with the Oasis MCX.
So Kim, we're using a couple different protocols here. How does that impact the data?
Yep, so the protocol actually makes a huge difference. Just like we saw with the Oasis Prime HLB, remember if we turned up the methanol a little bit, we saw a lot more elution of the phospholipids. Here, when we follow the Oasis Prime MCX protocol, we're able to decrease that phospholipid amount in the final eluate 58-fold. So you can compare that. Right, you can compare that and see that we've dramatically decreased the amount of phospholipids in that final sample eluate simply by using this Oasis Prime MCX protocol.
Cool.
So JT, we saw the data.
Yep.
This customer was asking specifically, they know that phospholipids are a problem that
Right.
cause matrix effects, column contamination, all those things. But their question was, really, they recognized SPE can remove them.
Yep.
But does it matter what SPE sorbent you use or what method you use? They thought, as long as we're doing SPE, the phospholipids are gone. What do you think?
Yeah, this is totally busted. Totally busted. There's so many different types of SPE sorbents out on the market, different protocols. If you want to remove phospholipids, you really have to understand what your sorbent's doing with the protocol that you're running.
You do, absolutely.
So I'll write this up and I'll get it back to the customer.
Let's do it.
Okay.
If you'd like your question to be answered on a future episode, please feel free to email us at trustyourscience@waters.com.